Hello everyone, welcome to our channel. In today's episode, we are going to talk about one of the most frequent ecosystems that you have undoubtedly heard about many times in the context of big data. That is none other than the Hadoop ecosystem. This is one of the well-known ecosystems for big data that aims to handle challenges from storage to analytics. Before we delve into the famous framework and explore its components, let's take a brief look at the history of Hadoop ecosystem. Initially, it starts as the Notch project in 2002. By 2008, it became one of the projects of the Apache Foundation. Finally, in 2011, the first version of Hadoop was released, and in 2012 and 2017 the second and the third versions of the Hadoop were subsequently released. For more information and details, you can refer to the Apache Foundation website. So, what is Hadoop and what problem does it solve for the big data? The Hadoop ecosystem is neither a programming language nor a service. It is a platform or a framework that addresses the big data challenges we discussed in previous episodes. Hadoop is an open source framework designed to make interactions with big data easier. It incorporates Apache projects and various commercial tools and solutions. When we were discussing big data concepts, we emphasized the challenges associated with big data in comparison to traditional data. We categorize these challenges into three categories: data storage, data processing, and resource management. These are three pivotal challenges that we need to consider when talking about big data. The Hadoop ecosystem is designed to address these challenges. Of course, there are more components in the Hadoop ecosystem for each layer of data. However, to better understand this ecosystem, here we present the three main components: HDFS, which is the abbreviation for Hadoop Distributed File System, MapReduce, and finally Yarn. Each of these components is designed to tackle one of these challenges. HDFS addresses the storage challenge, and MapReduce handles processing issue with big data, and Yarn, as a component of Hadoop ecosystem, is designed to solve the resource management problems. In other words, Yarn is responsible for managing workloads, monitoring, and security controls implementation. It also allocates system resources to the various applications running in a Hadoop cluster while assigning which tasks should be executed by each cluster nodes. Yarn itself has two main components: resource manager and node manager. As you can see, there is a general relationship between Hadoop components and the big data challenges we discussed before. Keep in mind that Hadoop consists of more than just these components, but at this stage we present this general view with these three components. We will delve deeper and explore more details in other videos. The power and the benefit of Hadoop ecosystem lies in the way of scaling. In the past, when we wanted to scale our system, the approach we had was vertical scaling. For example, we would improve the resources of the system, such as CPU or RAM. However, in this ecosystem, scaling is horizontal, which means we can empower our system by adding different instances and distribute different layers of processes in different clusters. As a very holistic and general view from the top of the Hadoop cluster, which is presented in this picture, we have one master node in the Hadoop cluster to manage and schedule different types of tasks. To perform each task, we have different worker nodes. Let us discuss and get a brief idea about how the MapReduce process data. MapReduce is a data processing layer of Hadoop. It has the capability to process large structured and unstructured data, as well as to manage very large data files in parallel by dividing the job into a set of independent tasks. MapReduce makes the use of two functions, map and reduce. The map functions performs sorting and filtering of data and organizing them in the form of group. Map generates a key value pair based result, which is later on processed by the reduce method. Reduce is performing the output generated by map as input and combines those tuples into a smaller set of tuples. Let's explain this concept through a famous example. There is a famous example for understanding MapReduce, and that is the example of word counting. As you can see, imagine that we have a document containing 3 lines, and our goal is to count each letter in this document. MapReduce splits the data and it counts the number of words in what we call the map phase of the process. Next, it sorts and shuffles the data to group the same keys together in order to make it easier to process. And finally, in the reduce phase, the desired aggregation is applied, which in this example, the count of each word is. And as you can see, the output is the count of each word in our document. Of course, this is just the simplified example of MapReduce to better understand its concepts. Since HDFS is currently used in different big data projects, it is recommended that you learn the most common HDFS commands to work with distributed file systems. Here we provide a few of these commands just as a sample, and of course in the references we will introduce at end, which we will introduce at the end of this section, you can delve deeper into these concepts. As usual, at the end of each video, we introduce more references for those involved in big data projects in order to broaden their knowledge. As the main and first reference, always check the official website of Apache Foundation, where you can stay aware of the latest versions of each tool developed in the Hadoop system. We also introduce 2 comprehensive and well-known references for the Hadoop system. One of them is a definitive guide for Hadoop, and the other one is modern big data processing with Hadoop, which focuses more on the processing layer. Okay guys, thanks for watching this video. We will provide more details about each of the big data technologies in upcoming videos.